Alright, now we're actually going to work on solving exponential and logarithmic equations. Some of this might look a little familiar because we have used similar methods back earlier in the chapter when we were trying to simplify logs. So, a couple options here. First thing you want to do, if possible, go ahead and make the bases be the same, and then set the exponents equal to each other. So, take a look at this first one. Number 1, we see a 4 here, and we see a 16. So, think if you can make both of those have the same base. We know that 16 is really 4 squared. So I'm going to actually rewrite this as 4 to the x is equal to 4, and I'm going to write it as negative 2 because 4 squared is 16. So that means 4 to the negative 2 is equal to 1 over 16. And I still have my x to the x plus 3 power. Now, since my bases are both the same, it's essentially like they cancel out. You're just going to set the exponents equal. So my equation is x is equal to negative 2 times x plus 3. I'll need to distribute that negative 2. X is negative 2x minus 6, and then from here just solve for x. So I've got 3x is equal to negative 6. And then you divide both sides by 3 to get that x is equal to negative 2. Now you can always plug this back in just to make sure that it really works. If you really want to make sure, so you have 4 to the negative 2 power. I want to check to see if that's equal to 1/16 x plus 3. 4 to the negative 2 is, oh wait, hang on, I didn't plug in my negative 2 right there. Negative 2 plus 3. Plug in x wherever you see an x. So now we have 4 to the negative 2 is 1/16, and see if that's equal to 1/16 to the first power. Yes, it is. It's not necessary that you do that, but it is worth it to make sure that you get the right answer. Alright, let's try another one. Again, I'm still working with this, if possible, make the bases equal to each other. So I've got a 9 and a 27. So what I usually do is look at the bigger number, 27, and see if I can change it to 9 to some power. That doesn't work because 9 to the first is 9, 9 squared is 81. But I might be able to make them both smaller. So if I start with the 9, I know 9 is really 3 squared, so I can rewrite that as 3 squared. I still have 8 minus x in the exponent, and now I know that I can change 27 to 3 cubed, and then I have an x minus 3 up in that exponent. Again, now that my bases are the same, it's almost like they disappear and we just set the exponents equal. I'll have to distribute, so I really have 16 minus 2x is equal to 3x minus 9. And then from here, just solve for x. I'll subtract 3x from both sides. I will subtract 16 from both sides. So then I have negative 5x is equal to negative 25. Divide by negative 5, x is 5. Again, just to make sure you did that right, you can always plug it back in to check. You've got 9 to the 8 minus 5 is really 9 cubed. And see if that's equal to 27 to the 5 minus 3. So is that really 27 squared? And then from there, get your calculator, check them both, plug it in, and you'll see that they both equal 729. So we did it right. Alright. Okay, I want to go to the next page. Let me go back. I want to point out one thing here too. Oh my god, that is so... before we go on, I do want to show you that sometimes it doesn't work to set the bases equal. If that's the case, if you can't set them equal, that's where the logarithms come into play. So what we would do is we would take the log of each side. A shortcut to this would be to change the exponential form into logarithmic form. So let's look at another one. X is up in the exponent, and there's only an x on the left. So what I'm going to do is I'm going to try to get that x by itself as much as possible. So I will add 2 to both sides. So I've got 2 to the x minus 1 power is equal to 32. Now again, if possible, balance out the bases. If not, that's when we're going to do logarithms. So if you look here, actually this time I can change that 32 to 2 to some power. So I've got 2 to the x minus 1 is equal to 2 to the 5th power. X minus 1, I'm setting the exponents equal to each other. X minus 1 is 5, add 1, and x is equal to 6. Now, I do want to show you, just so you can see what a logarithmic problem looks like. Let's say we got to this step where we have 2 to the x minus 1 is equal to 32. Let's pretend like it wasn't really possible to balance out those bases, because here soon it won't be. One thing you could do is you could log both sides. Now what I would actually do is decide log base 2 so that this left side would become just x minus 1. If I log base 2 to the left, I would have to log base 2 the right side. So on the left, all of this would just kind of disappear with properties of logarithms, and I'd have x minus 1 is equal to, if you can't simplify this, you can go back to your common logs, change it to log base 10 of 32 divided by log base 10 of 2, type that into the calculator, and it will be 5. You know, sometimes it's going to be an ugly decimal, and then you can just go from there, but you would get the same answer. Now I did point out that there was a shortcut. The shortcut honestly isn't much of a shortcut, but if you start with 2 to the x plus 1, or sorry, x minus 1 equals 32, you could change it to log form. Log base 2, remember base is always whatever had the exponent, of 32 equals the exponent. And this was one of the first things we did with log, was change it to log form from exponential form. Notice you're at kind of the same place we were before. Type log base 2 32, change it to common logs, which is actually what we have here, and then you'd have 5 is equal to x minus 1. So I just showed you 3 different ways to do this. You just kind of pick what's going to work best. Take a look at number 4. Again, I have the x up in the exponent. Please don't think that there's 2 variables here, because remember, we learned earlier that e is just a number. So what I'm going to do first is I'm going to add 7. I'm trying to get that x by itself. I have 4e to the negative 0.3x is equal to 20. From here I'm going to divide both sides by 4 because I'm still trying to get that x by itself. And I get e to the negative 0.3x is equal to 5. Alright, now, it's really not possible for me to balance out these bases. I have no clue e to what power is going to equal 5. So, at this point, think about what logarithm you would use e with. So, that would be a natural log. So I am going to natural log both sides. Because remember, the base that you don't see is e. My left side, all this is just going to kind of disappear, and I'll have negative 0.3x is equal to the natural log of 5, which, yes, that's going to be an ugly decimal, but we can just use a calculator from here. Divide by negative 0.3, and from here, just use your calculator. You know, type it in, be careful. Remember, when you type in the calculator, you'll have ln. It will automatically open up a parenthesis, so you need to close the parenthesis before you divide by negative 0.3. But you should get negative 5.36, negative 5.36. Mine says 479, so I'd have to round that up to 5 if I'm going, you know, the thousandth. Now, the shortcut. Again, not a lot of a shortcut, but if I go back to right here, I'm going to open up a new page here. Alright, I cleared everything off except for that. E to the negative 0.3x is equal to 5. Now some people like to just natural log both sides, like we did here, and right here. And that, that works out great. If you want to change it to log form, you would do log base e. Well, as soon as you think log base e, that becomes ln of 5 is equal to the exponent, which is negative 0.3x. Exact same problem that we had on the front, or in the last one that I did here, but you'll get the exact same answer. So, you look right there, same thing that I'm doing right here. So I'll get the same answer. Alright, now we're going to move on and try some logarithmic equations.